I'm good, Saurabh. How are you? Great, great. So I'll be waiting for a couple of more minutes before we start the session because I want to give some additional time to people to so that they join because it's Sunday morning and I'm glad you guys are here and yeah, that's really great. So just a question. So what energy drink have you guys chosen today morning before joining this session? Like I chose a black coffee to to be awake and be there in the session. So let's see what is your go-to drink? Ashutosh says a black coffee or a sunlight, cup of tea. Yeah. Hi, Alagesh.
Hey, hi, Akshit. Morning.
Hi. Good morning. Vikas says he drank a cup of tea. Yeah, that's great. Yeah, because Sunday early morning, you're probably in the mode of Monday again. Monday is arriving soon, and you guys would be hating this morning, right? Hi, Alan. Yeah, Saurabh.
Hello.
Yeah, hello. Yeah, Saurabh, I hope Golan was a drink to give me energy, but yeah, that's the fuel that keeps the weekdays going. But weekends, yeah, definitely you need something else. Okay. Right. So we have a good number of people who have already joined. Let me start the session. Let me start sharing this. I hope my screen is visible. Can you guys give a thumbs up or something so that yeah, if you can see the screen.
Yeah, shit, the screen is visible.
Okay. So I'll start with setting up the context for the day, what we are planning basically, right? So that it's easier for you guys to navigate today. Give me one quick second. There is okay. Yeah, so today we have arranged this session so that we can start discussing on the weekly challenge that we have on our Discord server, basically. And I've also initiated that on LinkedIn. So this weekly challenge is to develop an API gateway. Now, what is API gateway and why do we need it in the modern application? We'll discuss in a bit. In today's session, I'll be navigating you guys through why API gateway is needed, what is the initial use case when the API gateway was introduced to the world, and what are the different components that are involved in API gateway. And soon we'll be going to basic implementation of the API gateway, which is not what is production ready, but at least a very basic wireframe which can help you guys scale that API gateway. And then we'll also introduce some rate limiters in the session today. Hope that sounds good. And then I'll open the ground for next week's challenge, and we'll keep extending this for a couple of weeks more so that this becomes kind of production application which you can start deploying on a smaller scale application, and you can keep extending it in the future if you guys. want, right? Hope that makes sense. So before we start, I want to understand how many of you have used an actual API gateway or are in being into development for some time and understand why API gateway is needed. Anyone?
Yeah, API gateways are basically for uh, the authorization and rate
Mhm.
limiting. Those are cross-cutting solutions can be uploaded to API gateway so that like our application focus on the business logic.
Makes sense. That is correct. The Jyoti also says that basically it's for routing, correct, Jyoti? And because I would appreciate if you can stop using the annotations. Yeah. Okay. So on API gate, an API gateway is just that helps you navigate your request to the right service, basically. And in the process, it also has to perform a lot of activities, and we'll be discussing what all things an API gateway does, right? But let's start with why API gateway came into existence. Okay. So if you if you guys go back to the time, I would say in 1990s or 19 late 90s also, the applications were basically a giant monolith, right? Now, by monolith, what we know is, let me admit. So a monolith is an application server which has all your code, all the business logic, everything that is talking to your database and everything. So this is one application. Let's say you are building an e-commerce platform. Now this e-commerce platform has to perform your order processing, right? Then it has to perform your authorization. It has to perform rate limiting. It has to perform the listing of the items. It has to perform building your wish list and everything, right? And also act as an admin portal where admin people who are listing their product can also be there, right? So this one application server had everything. It was playing a role of a multiple personality now. Now, it was very hard. It was becoming very hard to maintain this code because, as you see, there are a lot of logic, lot of business things that to this one application is driving. Now, let's say someday you find an issue with your order processing system. So you cannot, you were not able to deploy just the order processing module. The complete application had to be deployed with the right fix. So this was and that eventually means that the complete application is down, everything. So if there is an issue with order processing, your listing, your wish list processing, or anything apart from that, for example, admin, where they're adding new items, everything goes down for some time, and then your application is started again. So this was becoming a very challenging environment to work with for a large scale application where there are a lot of use cases and business things. This was monolith applications. So then what people did started doing is breaking this down into smaller application so that it's easier for you to deploy the changes for a delta issues, right? Now what we started initially is we created smaller application. One is order processing, then maybe login. Login is a module. Then we also did, let's say, admin, where admin is managing their inventory, right? And so on. Now, client, that is your maybe mobile or web application, they were calling these different API servers independently. Now, if let's say you want to do authorization logic had to be put in all the microservices apart from the login, definitely, but it had to be placed in in all the other microservices. If you're doing some kind of rate limiting where you're protecting your server from getting overloaded, that rate limiting logic is also sitting in all these server now. Now that means that any team who is responsible for order processing, if they're trying to fix some issue with the rate limiting logic or maybe authorization logic, it has to be navigated and it has to be told to other teams also that can you please fix it. Otherwise, this module particularly would have the right fix, but the other modules still have the issue with those common things, right? Common functionality. I'm not talking about the exact business case that these servers are meant for. Now, this was again becoming a challenging environment to do, right? Because the common logic that sits in all the application has to be maintained by every team, right? Hope that makes sense. Quick reaction, guys. Okay, that's good. So now, what some developers thought about is why not introduce one service that has all the common logic that has to be put in all the different services. This service that was created is called as API gateway. Now, the sole responsibility of this API gateway is the client would not have to talk to 10 endpoints. He will only talk to one endpoint. And this endpoint will make sure of all the common logic that is related to your authorization, rate limiting, security features, request logging, anything, right? Everything that has to be in every service is now over here. Now, there are separate use cases where we break this down into separate pieces also, but let's not get there right now. Now, this API gateway's responsibility was that it takes in the request from the user or the client, finds the right service for that request to be served, and navigates that to the right service. Now, that service already knows that the request that I'm getting is already very validated for the request limiting, the rate limiting basically. Then it is also validated for any security threats in the request, right? Because that's the responsibility of API gateway. And now it has to only perform the business use logic then. So now this service is offloaded with all that common logic and it will only perform its own basic logic. So this service becomes the checkpoint where all the requests will come in. Now, if this is one service, you definitely need all your security and every rate limiting protection of your original services against any kind of threat. So this service will take care of your server protection. Hope that makes sense. Okay. So our challenge is to make this service. This is what we are trying to do in this session today. Today, I will only introduce you to what type of modules should be there in this service. How does this service know that how many instances of order processing is there? So that's a challenge, right? Let's say there are five servers for order processing now. Now, someday out of this five server, there is one server which is dead, which goes away. How does this service know that this one server is gone now and I should not navigate users to that one service, one particular server for order processing? How does that happen? All those things we'll discuss on on a high level today, and then we'll navigate and we'll be building all those modules one by one in the coming week, not today. We have some part of rate limiting we'll discuss today, but all these things will be coming up in the forthcoming sessions that we'll do. Now, if you understand the API gateway, you should also understand that there are few pros and cons of API gateways. Now, pros are always that you have just one service that the client has to connect with, then all your security and everything has been put into one place, everything, so that other services do not have to worry about all those things. So I have one point from Alagage. Let me take that. One more point. Only API gateway is publicly exposed and the other services are within the internal. Yes, that's true. So Alagage, you're correct. So these all services are never exposed to the internet overall. So it's not publicly exposed. Only API gateway will be publicly exposed so that anyone who comes to your server wants to reach your server is reaching to the API gateway. It's the check checkpoint place where everyone reaches, and it's the responsibility of API gateway to take that request to internal private protected VPN or VPCs that we are talking about. Right. Now, pros of API gateways, all your common security logic, rate limiting, all your authentication, authorization, everything can go into this service, and all the actual business services are offloaded of all those things. That is one thing. But there are cons to this also. Now, what are the cons? Can you guys quickly think about some cons that you are foreseeing right now before we move forward? Single point of failure, right? Any other thing? Additional routing, that is correct. It increases the latency of your request because it has to hop, give one more network hop. That's true. Hmm. And one more thing, you have to also make sure that your routing, for example, there are five instances of order processing. API gateway also has to check that how will it balance the load between these five services. If you are not able to balance the load in five services and you're always pushing your request to the first available server, then again the problem will occur where only one server is always overloaded in order processing and other servers are still sitting behind. They are not practically being used, right? Yes, Vikas, that is true. So it requires more resources to handle more requests per second. That is correct. That's again one more cons of API gateway. But API gateway, I would say, is not actually involved in any business logic that talks to the database. It's just filtering. So you cannot say that it will spend a lot of time, but you definitely need a lot of bandwidth on this server so that people can send in more requests. So if let's say your login server says that I can accept 100 requests per second, and order processing says I can take 50 requests per second, so that means your API gateway on a holistically, should take at least 150 requests per second. Your API gateway server should support that, but out of which it will only accept 100 requests for login server and it will only accept 50 requests for your order processing, and rest requests are always denied. But it should have a capability of serving these requests at least, right? So API gateway is always the heaviest machine that you would have on your server. Then there is an operational cost, right? Earlier you were only having these servers to manage, right? This is one more additional infrastructure cost that you will bear now. That is a very big challenge for any small scale product. Understood? So all this combined together, but still people still want to use API gateway is because of all that benefit it is giving you against your replication of code, maintenance, and everything, right? Now, let's go to understanding what components or how a rate limiter is designed. API gateway is designed, sorry. So, an API gateway, let's say there is a login service, then there is order service, right? All these service, as soon as there is an instance that get created or is initiated, it should register itself somewhere, right? So that API gateway knows that there is one instance for login service. right? So what happens is usually we either say that we have a service discovery that where these login service, any instances, if there are 10 instances of login service, all those 10 instances will register themselves with the service discovery. Similarly, with the order processing, and as soon as any one instance goes offline, that also has to be informed to service discovery. Now, if there is a panic that happened or there is some issue that happened on the server, it's completely offline. How would service discovery still know? Because that server will not inform right now. It's offline. So it's the responsibility of service discovery module to see if the services that it knows, the instances of that that it knows, it starts connecting to those service on a regular duration to check their health. So that means service discovery needs a health check to always keep an updated list of all the login servers. So service discovery maintains a routing table. Routing table says that I have a login, let's say login service, and I have this one instance. It will have the IP address. It will have the IP address of the second instance of login service. It will have IP address of the third instance of the service. Same for order processing. This is the routing table that the service discovery will have. Now, using this routing table, service discovery's responsibility is to connect to each one of these instances on a regular duration or ask these services to connect to service discovery. There are two models always implemented. There is one is pull based and one is push based. We'll not talk about that in detail, but let's say somehow service discovery is being able to connect to these three instances of login service every now and then. Now there has to be a frequency, but that's a separate issue. Every now and then there is a call that gets from login service to service discovery that I am alive, or service discovery makes a call to login service and says that are you alive? Give me your status. Right? Now, through this, the routing table is always kept up to date. That is your health check that does that. So service discovery also implements the health check mechanism to always have a list. Now, API gateway, whenever it receives a request, it says to service discovery that I have received this request. Can you tell me what route or what service I have to look for? Now, service discovery will say that okay, if you have received a login request or logout request, it has to go to login service, right? Now, out of three instances that service discovery has, it will give all the three instances to API gateway. Now, API gateway goes back to its load balancing module and says that tell me which service, which exact instance I should call, right? So now that becomes a part of API gateway. That now it will do the load balancing between the three instances of the service. Which instance has to receive the request. Now there are different ways to do that load balancing. There is like you multiplex that request based on the IP address. You hash the IP address of the client and then do that navigation to a particular instance. Or there are round robin logic, and there are different logic that each API gateway has. So you can choose any of those uh, load balancing logic for yourself. Hope you are understanding things of API gateway till now. If you have any questions, I would appreciate to take those questions now. I'll take a break of 5 minutes and let's see if you guys have some questions on this. You can unmute yourself to ask the question as well. Okay, if there are no questions, either I'm too good or I'm too bad. Now, what is the case? Like, can you guys give me a thumbs up or thumbs down if you Okay, I see a thumbs up. Okay, so that means you're able to correlate the informations for this as of now, right? That's not going or bouncing off your heads. Because this, I want you to understand fully so that it's easier for you to understand what modules and how to design those modules, right? And how to extend the server, keep extending it, right?
So, couple of points, Chit.
Yep.
Yeah, this is
Yeah.
good understanding. So, one point is, so a load
Mhm.
balancer could be a separate, service for your
Yes.
application, right, into the Kubernetes
Mm.
environment, let's say. So that can be
Correct.
offloaded from the API gateway, right?
Definitely. I'll come to those points because anything that I'm saying in API gateway, for example, logging, right? Or your rate limiting, anything, any particular module that I'm talking about over here can be a separate service altogether. But there is always a pros and cons to everything, right? Let's say if you introduce one more service for load balancer, that takes you to the right place, right? That is again network hop, right? But if it is
Mhm.
inside the VPC, it is very minimum, but there is definitely a network hop. So you will have to choose whether you want that logic to be inside API gateway or outside. It depends on how big your project is and how small teams do you want to manage. So at times, let's say if your project comprises of 1,000 developers, right, who are
Mhm.
managing 10 services, out of which one is the API gateway, it becomes really hard for that one team to manage all these logics for other 990 people, right? And then you see that your network all is not too bad. Now you can afford to have smaller modules or smaller services for other things. That is definitely there. And Kubernetes, when you talk about the Kubernetes
Mhm.
load balancer, right? It
Yeah.
is definitely used. So that's what I'm saying, that once you get the login service from the service discovery, it's on the API gateway, whether it will take care of the load balancing logic or it will offload that to Kubernetes.
Okay. And one
Hope
more
that.
point. So,
Hmm,
yeah, service discovery you mentioned at
hmm.
API gateway, and there is one more service discovery at the service or the application side, which is driven by service mesh. So, how it is
Hmm.
different from this one?
The API gateway's service discovery is to understand what all services do I have. Is there any validation logic? Is there any authorization, authentication logic that I have to apply on those requests? And the one on the service mesh is tightly coupled with your load balancer logic to understand whatever. So in those scenario, what happens is this routing table will not take care of all the instances over here or the health
Mhm.
check. That that thing inside the service mesh, right, that you're talking about, will take care of the health check in instances.
Yeah, right.
It will keep checking what instances of login services are alive, or if there is a new instance of login service that is needed, basically. So, for example, if your configuration says that I always need 3 instances of login service, and it can scale up to 5 instances based on the requirement. Now, service mesh and the service discovery sitting there will take care of understanding if there are less number of instances than required. So if
Mhm.
somehow there is one instance that has gone away and you're only left with two, so you, even if you don't have load, you definitely, your configuration says that I definitely need 3 instances always up. I cannot live with two instances, right? So that
Mhm.
is what is taken care by the service mesh and service discovery there. So I'm more
Okay.
talking about an holistically API gateway right now, and
Mhm.
slowly everything. So once we move forward in the development, right, we'll be
Mhm.
using all these service mesh, Kubernetes, and everything slowly. So I just want right now for you guys to understand how these single components are built, because until unless you write these components, you will not appreciate, oh, that is out of the box given to you by Kubernetes. Or what's the
Mhm.
difference between you implementing it versus the already existing implementation, right? So you should at
Mhm.
least understand the basic things around it. So that's the core logic me introducing you to all this right now.
Okay, I understood. Thanks, Archit,
And
for
any other
clarification.
questions or doubts?
No, thanks. Yeah.
Okay. So anyone who has doubts right now, I'll still wait for next 2-3 minutes.
Uh, Hi, Archit.
Hi, Saurabh.
Yeah, so if we talk about the ideal flow, so now it will be like the user tried to hit the API gateway endpoint, and from
Hmm.
the, let's say it wants to log in into the application. Then first the request will go to API gateway. From the
Hmm.
API gateway, it will figure out that okay, this is a login endpoint. Then it
Right.
wants to check whether it is validated or not, like
Hmm.
proper arc, like request rate limiting and everything is good or not. After
Hmm.
that, it will try to find out all the login services server from
Yes.
the
Instances of
service
login
discovery.
services.
Yes,
Yes.
correct. From the service discovery. After that,
Hmm.
it will try to check if which are alive through the health check, you can say.
No, which are alive is already checked in background. It is not when you call the request, right? So let's say
Correct.
if I say that I want to log in to your service, now I see that API gateway sees that there are 5 instances of login service alive, right? Now, not alive, but it's in routing table. Now, if at that particular moment I go to each one of these 5 instances, for you, the latency will increase, right? Because we are already talking about one network hop. But if we right now at this particular instance for your request, I go to 5 instances of login service to check which one of these alive, it doesn't make sense, right? It will increase your latency. So that's why I'm saying that service discovery's responsibility is to make sure that it always have the right list of instances that are there. So that's the core responsibility, and it is always taken care in the background. Right now, in the request flow that you're talking about, when you are calling the login API, API gateway does the rate limiting, that is true. Now it goes to service discovery, says that gave me the login instances that are alive right now. Service discovery gives it 2 or 3 instances. Maybe take that to the load balancing logic. Or if service discovery says that there is a separate load balancer, let's say that we are discussing about Kubernetes, right? So if we use Kubernetes, then there are not 4 instances or 5 instances that are registered over here. There is only one instance that is registered always. And that instance is internal load balancer in the Kubernetes for login. And that internal load balancer is now talking to service mesh and service discovery inside Kubernetes, which navigates to the right login instances. So there can be a couple of different more configurations that you can talk about. But the core responsibility of service discovery, whether it is with the API gateway or inside the Kubernetes, is to make sure that it has the right list of live services and it gives that back to the load balancer so that load balancer can balance the load on those instances.
Got it. Got it.
Uh, yeah. Any other questions or doubts? Okay. Till now, we have understood how the API gateway should act. What all different things are there in the API gateway? Now, let's do one thing. Let's understand whether, let me show you a high level diagram of this thing, what we have already discussed. I hope my screen, my Visual Studio Code, you can see the draw.io diagram, right? Okay. So now what we have already discussed, you can see that this is the okay, this is the API gateway that we were talking about. And these are the different login surveys, user surveys. They're talking to their independent databases. As soon as, I would say, as soon as the login service is alive, there is one instances of login service, it will have to register itself to the service discovery that there is one instance and I am for the login service. Similarly, the user service also registers itself to the service discovery, right? Now, service discovery has a routing table where it maintains all the instances for the particular service. And now, whenever a user is making the request, always goes to the API gateway. Now, API gateway talks to service discovery and calls the right service instance using the load balancing logic. Now, all that can sit in different places. That's a separate discussion. I leave that for the enhancement. We'll keep enhancing. Right now, my intention would be that our API, single API gateway, is doing the service discovery also. There is no separate service for this right now, let's say. Our API gateway is taking care of all those things. And once we start scaling towards the end of this challenge, right, we'll start breaking this down. So that's why whenever you are writing the code, make sure that you write the code in a smaller modular way where you can just pick up the code and put it in a separate service any day. With very minimum changes, you can create a new service within few hours. So make sure that your API gateway code is extensible and breakable to different modules. It's not tightly coupled, right? So this is a very high level diagram of what API gateway will do. Now there are a few more challenges that I would want to introduce over here. Now let's say this user is sitting in USA. This user is sitting in India. There is just one API gateway, right? Can that can that serve the complete globe? No. Single API gateway cannot serve, let's say, 10 million users a day, right? It's too high and too risky for a fault-tolerant system. If your system says that I cannot bear with a downtime, you cannot have just one instance of API gateway anytime. So that's why you always create different API gateway. Now, if you have ever noticed, when you click on Amazon.com, right? As soon as you click on Amazon.com, you are navigated to automatically, this site gets navigated to Amazon.in, right? Or if you are connected to a VPN and you are connected to a USA VPN, then it might go to Amazon.us or something. It might go to Amazon.uk if you are on UK's VPN. Have you guys noticed this thing? Yeah. So this is called scaling your API gateway. What these guys do is that there is a single API gateway. Only responsibility of that API gateway is to serve the Amazon.com and understand what region the request is coming from. Now, as soon as it sees that the request is coming from India, it will redirect the user to a different domain altogether that is sitting in India to reduce the network latency for the users in India. Now, what happens is now there is one API gateway that is a global API gateway. It redirects the user to the right smaller API gateways that are region specific. So you as a client who talked to Amazon.com, it said that you now get connected to this API gateway. Now, whatever request that you are making is talking to the API gateway sitting in India. Now, this India API gateway has its own instances of services deployed within the India Indian data centers. That makes the latency of your request smaller. Right now, you're no longer talking to the global API gateway, which might be sitting in somewhere. Let's say it's sitting in Ireland. For you, if your request always goes to Ireland and from Ireland it goes to some server, it will take time, right? Compared to your request going to a server sitting in India, right? So that is also something that people do nowadays, where to expand their horizon on serving the users. Now, this thing also helps you scale the deployment. So, for example, if you want to do a deployment of login service, you don't have to deploy it in all the regions altogether. You can choose a different deployment mechanism where you say that right now I'm seeing a less load on India time zone. It's a offline time for India. Let me first deploy it in India time zone, Indian servers. Then deploy it to some other server, which is the second level server which goes offline little late, right? And so on. So there can be a rolling deployment that you guys can do. So this is how the actual API gateway or actual servers are doing right now, but we'll not go to this extent because doing this involves a lot of cost because you'll have to bear a lot of instances on API on your cloud and to test all this. We'll only take care of designing one API gateway, which is a heavy API gateway, which does everything and redirects that request to the right service instance. And slowly we'll break that into smaller pieces. Take into account Kubernetes cluster even, right? To offload some of those things. We'll do all that. So this diagram, I hope this is clear and uh, crystal clear, basically. Okay. Now I'll move to the next part of it. That is the core interesting thing that we are discussing today, and that is the low-level design of an API gateway. What all different things do you need in an API gateway? And then we'll go to the rate limiting logic and what we do with the rate limiting. Now, an API gateway ideally needs a logging module which does all the request logging irrespective of the request getting throttled. Even if you are receiving a bad request from a user, which is maybe security threat, or maybe you're receiving more requests than allowed, you still want to do that logging so that you can create alerts based on those logs. You definitely need log before, even if you see that there is some security threat in that request. Give me a thumbs up if you agree with that. Okay. Okay. So first part will always be your logging module in API gateway, which has to log every request irrespective of anything that happens in the API gateway, right? And it also has to log your response. So that's why the request goes from login server to other places. And once the other place they have done their due diligence, the request is always navigating back from the logging server. So that's why this is a middleware. This is just not a module, it's a middleware in your API gateway where the request will travel from this and the response will also go back from this in the end, right? Then you have a monitoring server where you do all the monitoring related activity, where you are maybe you're monitoring your requests on which server you are receiving more requests. Maybe in some particular time you're receiving more requests on your order processing. You need an alert to raise an alarm to your order processing team that there are a lot of requests coming in. Can you be alert? There can be some issues also, right? So all those monitoring can be there for throughput, everything, right? Then your security comes into play, where you are saying that I want to block some IP. So if you guys remember, there was uh, Russia and Ukraine war where lot of services they denied their services in Russia, right? When Russia and Ukraine war are there. So they basically block those IPs, all the IPs from Russia. Or there can be some place in the world that is identified as a place where there is security threat. There are a lot of hackers sitting around that. So we want to block those IPs. Or if we have some basic logic on validating your request payload, that also can sit inside the security middleware, right? It does validation. If it fails the validation, the request is redirected back from here. Now, trust me, all these are smaller middlewares and they can be separated out and created as an independent service if you feel so. But creating additional services will always create some network latencies, additional network latencies. So we'll have to be mindful of dividing these into smaller pieces. Now, after the security is kicked in, we also do a rate limiting, a very basic rate limiting that is IP based or let's say physical address, MAC address based rate limiting, where you say that from this IP, I will only accept so many requests. So, for example, if you I at least was very energetic in creating a lot of email IDs back in when I got access to my first time laptop and computers. It was when I was in 11th and 12th. I used to create a lot of email IDs for me, myself, my friend, and do all that stuff. And then I realized there is some kind of logic that they have where they say that from this particular IP address, we will only allow 5 email IDs, or I don't remember the exact number, these number of email IDs to be created within month. So those kind of logics can be applied over here where you say that I will only allow for this particular request, these number of requests from this IP or MAC address in a month or in a day or anything. That is your first level rate limiters to also protect your server from DOS attacks. Hope this makes sense till now. Okay. Now, after your request has passed from the very basic rate limiters that says that, okay, the request is still good, it can be processed further, you go to your routing module, which talks to service discovery and gets to know all the available instances of the particular service or particular route that it has to navigate to. So now it will go to service discovery, check, say I have a request for login route or logout route, let's say. Now service discovery will say that I have these routing and this routing endpoint is for this particular service, and I have 10 instances of this service. These are the 10 instances. And this route is authorization protected or not. If there is authorization protection on the route, it will inform the routing on the API gateway. Now, API gateway says that, okay, there is an authorization. Now, that authorization can happen from a third party server. For example, in AWS, there is a Cognito service. You can do that, or you can have an in house service for your authorization. That also can happen. So now, at least from this service discovery, it knows that it has to do the authorization and whatever logic, maybe you are doing role based or anything, all that is provided back by the service discovery. Now, service discovery knows this all because the actual instances of the service have registered themselves and would have shared that metadata with the service discovery already. That these are the endpoints that I host. This is the security that it has to apply, basically. And security means the authorization or any kind of model authorization, model validation it has to do, which goes into this part. Right now, if there is authorization that takes care of validating if the user can perform the action or not, or all those things, that after doing all this, it goes to rate limiting again. This is a challenge. Now, you say that over here it was an IP base. Now, at times you are saying that have you guys worked with some API servers where you're calling those API servers and they say that you have this API key, boss, and this on this API key you can only make 10 calls per second or maybe 100 calls per second. There is some kind of limitation on the API key. That means that single user can only make so many requests per second. Have any one of you worked with such servers? Okay. I don't see any reaction, but I'll give you one example. Back in the day, I was working with HubSpot, right? HubSpot APIs, where we were syncing few data. So HubSpot, we had the API key to talk to their APIs, and it has a limitation of 100. If I'm not wrong, it was 100 requests per second. So each API key can only make 100 requests per second, right? Irrespective of the IP address. Now, if I use the same API key and you are using the same API key, it doesn't even matter because that same API key can only make 100 requests per second. And that made our life little harder if we were multiple developers working there because we had to make sure that we all sync together and see that we don't make 100 requests per second, right? In all, right? So those kind of rate limiting is there. This is bucketing over here. Now, bucket can be based on different logic. You can say based on user, maybe based on role, maybe API key, whatever is your logic for after authorization and you understand the user is good. Saurabh says Reddit. Yes, Reddit also should have some kind of rate limiting on the tokens. Yes. So most of it, every server that allows APIs to be exposed to the user based on the authorization, they will have some kind of rate limiting for each user. It's not on the IP address, so that it makes sure that the user is not over consuming their server. What if your original server can only handle 1000 requests per second, let's say. Your server is only built for 1000 requests, and now out of that, one user, and you have 100 users, let's say, registered. And out of these 100, only one user is consuming 900 requests per second. Your server is consumed by one client only, and the other clients have to live with only 100 requests per second, right? They are only now 99% user are only making 100 requests. Is that fair for them? No. So that's why. So you cannot do that. And Saurabh, you are right. There are different type of rate limiting for each API. For example, if there is free account, you only allow 10 requests per second. If you are a maybe a premium member, you are allowed 100 requests per second. So all that is custom rate limiting logic which goes into this place, right? And that is not applicable to your all instances of your service. For example, login or order processing. It's not related to that. It's just that this rate limiting is your overall application's business logic. So this rate limiting is very important, right? Then there is load balancing. Definitely, you do the load balancing. You redirect the request to the right server, and as soon as you receive the request, a response from the server, you transform that and send it to the client. And how do you send it to client? You navigate back from all these middlewares back again, and it goes to your logging, and then it goes to the client. Hope this is clear.
Yeah, it's clear, Archit. And I have a question here in the load balancer part.
Mhm.
Um, so, for example, we are making a round robin or any kind of load balancer. We need to know about the list of services and where it is got deployed, right? So,
Yes.
like in that module as well, we need to talk to the service discovery to know about the services.
No, so service discovery, already you have talked about that. You have interacted with service discovery when you were doing routing, right?
Hmm.
You already will get all that information over here.
Okay.
So
So,
the service discovery will tell you that, okay, this is the route that the user wants. This route is for XYZ service, and I have 5 instances of service. Now you do your due diligence. It will respond back all the 5 IPs, actual physical IPs of those 5 instances,
hmm. And
which now will be provided to load balancer, and load balancer will do the nitpicking of one instance and say that now navigate that request to that.
okay, so in case if API gateway is distributed
Hmm.
and so I have uh, for example, two service, two IP. For a service, I have a two instances.
Mhm.
There are two API gateways just serving it. There are chances that like always we pick the first one in both API gateways, right?
Okay, so that scenario you're talking when you're saying that there are in let's say the India API gateway and there is US API gateway,
Hmm.
and there are two login services, right?
Hmm.
Both of them will refer to this login service. That's what your assumption is.
Yeah, I'm just thinking like how we are going to maintain a state of say like I have a five APs and I have already served first one. For the next request, I need to serve the second one.
Hmm.
And how we are going to maintain that round robin within the API gateways.
Yes. So basically, what happens is when you divide your service like you have a lot of API gateways, right, in each region, right?
Hmm.
So you don't talk to single instance of the service. Now, why is that? Let's say this instance, these two instances are, one of them is sitting in USA
Hmm.
and one instance is sitting in India. Can
Hmm.
be possible, right?
Hmm.
Now, if India instance, you are saying that, okay, API gateway user is reaching to the right API gateway to reduce the latency, but internally it goes to USA login service.
Hmm.
That doesn't solve the actual problem of latency. It again brings up the latency into picture, right? So
Uh,
in this scenario, you don't use this configuration. You actually, I'll remove all the drawing. What you usually do is this is your API. This is your overall gateway
okay.
worldwide,
Hmm.
right? Which navigates the user to these gateway. Now this client is no more talking to this API gateway worldwide. It is talking to India gateway.
Hmm.
Now, this it has its own deployment. It has its instances of login service sitting in India VPC.
Hmm.
VPC in the India time zone,
Hmm.
Indian service. This
Hmm.
is USA.
Hmm.
It will be talking to separate set of VPC,
Hmm.
which is sitting in US only. It has its own login instances. So it's
Okay.
like multi-region deployment. So you have deployed your service in two regions, all instances. So five instances of login sits here, five instances sits here. So
Okay.
over here, this API gateway will only talk to either of these five.
All right. Okay. Let's come to the India part alone. Like India
Hmm,
itself, we have five services.
hmm, hmm.
So API gateway is a stateless, right? Like API, for example, inside India itself, we might be having uh is it a single API gateway instance for India?
Yes, it will always be one instance, but you will have replicas of API gateways over here, which all talks to the same VPC. Now, why I say replicas of API gateway servers, let's say if the first server goes away, my client can still talk to this API gateway.
Okay. So in
The
that,
second instance, I have a backup instance. It's not active instance. It is always like a passive instance that's sitting behind to take care of if the first actual instance goes off.
okay. So now, my actual question here is like, when it comes to load balancer, and I have five instance and five APs.
Mm,
So one request is served with the first IP, and when the
mm,
next request comes in, the
mm.
next request doesn't know that like already the first instance was already served, right? There should be some
Okay.
distributed cache or something needs to be there where the state is maintained for all the API gateways to know about like how we can round robin that.
Yes, that is true. And that is the core part why a load balancer I have created as a separate logic. Or
Okay.
this scenario that you're talking about is a valid scenario where you're saying that first request goes to instance one of
Hmm.
login service, second request has to go to instance two at least.
Yes.
But how does that even matter? Let's say if it goes to instance one, if instance one is free,
Hmm.
right? What ideally I want from load balancer it is that I should not send more requests to one. Let's say this server can only serve two requests per second,
Hmm.
right? Requests per second. This server can also save requests per second. Now, if there are two requests coming in 1 minute duration, that first request came in, and after 1 minute, first request another request came in, and both of these goes to the first server, it doesn't matter, right?
Uh,
It's okay because that's the duration topic that we are talking about in the load balancer. So it's always that how many active requests are there, and for checking out the active request, you might need a caching server, you might implement some other different algorithm, or you might stay consistent hashing kind of algorithm where you are saying that time-based consistent hashing you can use, where timestamp can be hashed and you navigate that request to the server, right? You have only five instances sitting on this consistent hashing ring, right? Now you use the timestamp as your hash key and you say that, okay, the hash value of this timestamp is this thing. It request goes to this. Second request comes again, it goes to this. It depends on what logic do you want to implement in your consistent hashing. sorry, in your load balancer to differentiate to distribute the load. No,
Okay.
Bhubaneswari, it is not related to CDN. CDN is the content delivery network that is not right now, not discussed right now. Alagesh, hope that answers your question.
Yeah.
So I would definitely say there are lot of use cases, lot of logic, lot of things that you have to take care while doing load balancing. But that is totally depending on the business case that you are solving, the request that you are number of requests that you are receiving. Let's say when I started my server, I have only 10 clients, right? I can still live with just distributing one by one, right? First request goes to server one, second request goes to server two, third request goes to server three. I can use a modulo operator basically, right? If the request ID is modulus 5, whatever is the response, I will go to that instance. With small number of users, you can do that, right? As your user grows, you will have to have very sophisticated ways to do that load balancing. And there are, I think, if I remember correctly, there are 7 or 8 type of logic that I remember correctly that are available in the load balancer, and each one of them has their pros and cons. Now, you will have to decide which one you need at that particular use case, your use case, basically. Hope that makes sense.
Yeah, it makes sense.
So, till now, we have understood what modules do we need in our API gateway, right? So, this was my week 1 challenge. Now, week 2, I said that we'll do. So, till now, today I'm discussing the 3 weeks, complete 3 week summary together again so that we can initiate. I'll give you guys 1 week to come to this point where we have already reached so that it's easier for you guys to navigate forward and keep implementing this. So in week 2, what I said is just create a very bare bone skeleton of your API gateway where you are not adding any logics to all these things. It's just empty. As soon as you receive a request in your logging middleware, it's navigated to monitoring. Monitoring you receive, you don't do any business logic, it gets navigated to security and all those. Now you might choose not to implement some of these modules, that is also okay. But there are some modules that you definitely need, which I don't want you to remove, is logging, definitely. This rate limiting, this routing service discovery, right? Authorization we can include in later part, and then load balancing and request transformation module. So we at least need these 6 modules, right? So that was the week 2 where we were not worried about logic, actual business logic in any of these things. We were only doing blank middlewares. We were only creating blank middlewares. And that was the week 2. Now, I want to discuss about this thing. Just give me 2 minutes to discuss this thing. There are 2 ways where API gateway can send the request or forward the request to the actual backend server. Now, load balancer says that talk to this instance. We'll talk to instance 1, for example. Now, to talk to instance 1, there are two protocols that you can use. Either use gRPC or use HTTP. My personal favorite is gRPC, but I am open to have you guys implement this using HTTP because this is a separate server, right? And your actual backend service is a different server. You can talk between these two services, have communication between these two services using any of these protocols, right? Why gRPC? gRPC is faster, and the packet size that is shared is smaller in size and is faster to decode and encode the data. That's why gRPC. And in actual service, it is the only thing that is ideally used, right? But we can start with having an HTTP way of forwarding the request from API gateway to your backend. Okay, yeah, Alan, thanks for attending the session, and yeah, I appreciate you taking out time from your busy schedule. So I hope you guys understand, at least have a basic understanding what is these two different protocols, and even if you have not implemented or used gRPC, it's still okay. You can avoid this for now. It's just one middleware. In future, you can just go ahead and change this middleware from using HTTP to gRPC in future. Right now, I don't want you to focus on gRPC or HTTP. Use comfortable. Just make sure that whatever request comes in goes to an backend server and receive the request response from the backend server, and it is navigated back. That's what the week two mentioned. You don't have to do logging. You just have a blank middleware. You just have a blank rate limiting, routing, everything. But just the request goes to one backend service. If you are able to make that, you are at least able to solve 20% of your API gateway, right? Now, the 80% is where we develop each of these modules separately. Hope that makes sense to you guys. Now, I'm little over time, and I would need little like 15 minutes more, because today was an cumulative session where we have already completed 3 weeks, and I wanted to take you guys through this journey because it has been a Diwali week and a lot of you guys have not, I don't think you have started this. So it is easier for you guys to at least have understanding and then start doing it.
Ông Tấn thì
Yeah, Jyoti, you want to say something?
Yeah, actually, I have one question
Mm-hmm.
here. See, the gateway will be doing the load. Let's say we have the load balancing in the gateway itself, and we are using some algorithm to route the request to the services, right? So,
Mm-hmm.
let's say, yeah, I mean, we are using some algorithms to route the services, and some queues are maintained. Like for this service, these many requests are for this instance, these many requests are going. For this instance, these many requests are going. Suppose say one of the instances gone down and it has some request in its queue. So how do we handle that? I mean, those what happens to those requests?
Yeah, that is again coming to the request and response plus the load balancer logic. So you will always
Okay.
have a mechanism that is established in this way, where you say that I've sent a request to this backend service and I'll wait for, let's say, 10 seconds,
Mm-hmm.
right? Now, within 10 seconds, if I don't hear back from the backend service, I'll pick up another instance of the service
Okay.
and send that. So you always have some timers on that response that you should receive from the backend service. But that is again, I would say it's a too deep going into the complete failure logic and handling all the business case, right? Right now, right now for this complete challenge, these things that you're talking about is very minor things that you will have to take care when you're doing it on a production scale. But to start
Mm-hmm.
with, we will not worry about that part right now. That is a true use case that you will have to take care in a production grade API gateway. But
Okay.
there is one more challenge.
Mm-hmm.
API gateways ideally are scheduled for 60 seconds, where we say that
Okay.
if the request is not served, so client has made a request and within 60 seconds, this complete process, backend is not able to serve the request back and client doesn't receive the data. We only have 60 seconds to do all this backend and everything. Within
Mm-hmm.
60 seconds, if the client doesn't receive a response, API gateway has a middleware which is sitting somewhere before logging middleware, which I have not discussed for now. it will take care of this 60-second timeout where it will cancel the context of the request so that everything gets cancelled, and it will send a response to the client saying that there is something wrong with our server and there is a gateway timeout where gateway says that it has spent over 60 seconds. Now that context is cancelled. Now if you're saying that if instance one is not able to serve the request, I have to switch to instance two. That's definitely something that you will have to do, right? So
Mhm.
you will also have to make sure that is again these two calls included have to be within 60 seconds. So that's why you will have to apply a separate deadline over here. Let's say 20 second or 10 second. Within 10 second, if I don't hear back from the backend service, I'm trying to call the other instance, right?
Okay,
So that's
okay,
how you
okay,
you do it. But that's a I would say that's a very intensive thing to develop for starting in the starting.
okay,
But it's a
okay.
very valid use case and it is definitely needed in any API gateway.
Mhm. Okay, okay. Thanks, Archie.
Yeah, thank you, Jyoti. Thanks, Sankit, for the feedback, but I hope you have not dropped. Yeah. Okay. So now you understand that how we will navigate and everything, right? Now in week two, week one was to identify all this high level design, low level design, what is there, read about the API gateway, and articulate all this information that I have just shared in last an hour. Now week two was just to build the bare bone where we have already built, and I have one. And this repository where we are building is a shared repository where I would appreciate you guys creating MRs, and I'll be reviewing those MRs going forward and accepting them. But for week two, I have already accepted one MR from one of the users where he has used gRPC. Now, if you guys want another way of interacting, maybe the HTTP way, what I would suggest is instead of week two, create a week two HTTP type of folder and do that HTTP way of forwarding the request to your backend service. Hope that makes sense. Okay. So I'll take the silence as yes. Now I'll move to the second important thing that I want to discuss today, and I'll need 15 minutes, last 10 to 15 minutes. The rate limiter. So rate limiter, we have basically five type of rate limiters available in the market. Okay. Yeah, thanks Gokul for attending the session. So we have five type of rate limiters available in the market, and I want you guys to put in all the five type of rate limiters in the API gateway, and there should be a configurable way to choose from any one of these any one of these rate limiters, and send in the configuration to it, right? Now I have written a very basic code, and I have an article that you guys can refer to. I'll go to that article. It's on LinkedIn. It's a free article where I've explained all the five type of rate limiters. I'll share this article link with you guys after the session also, right? After the session, you'll probably receive an email in some time today, at least today. So I'll share this thing with you guys, all these articles. So there are five type of rate limiters, and I've explained each one of them, and there is also a code that is associated with each one of these rate limiters, which is also part of the article, right? So I'll not go in deep of all the type of rate limiter, but what I want ideally is you guys writing a logic to have all the five type of rate limiters over here, and from the configuration, the the client can choose who is running the service. They can use any type of the rate limiters, right? So that's what you have to implement, all the five type of rate limiters. And Service discovery is something that we'll do in the next week. This week, your target is to complete the 5 rate limiters and make the logic extensible, where from the configuration, the client can choose the not the client, but the admin who is trying to run the service can choose what type of rate limiter he wants to use in their API gateway. For example, you can see that in the environment configuration, I have said what type of rate limiter, right? And then I have implemented three over here. For reference, you will have to extend this to other two as well. So this reference code is already there in the uh, repository that I'll share. Let me share that repository with you guys. Okay. So the repo code is this thing. I have already put in place in week 3 the rate limiters, 3 rate limiters over here in API Gateway inside the package folder. I would appreciate you guys adding to top of this and making sure that in the factory you write the right method to use or instantiate that particular rate limiter over here. I hope this is this challenge for this week is clear. And next week will again schedule the same session, right, for understanding the rate limiters in detail. So I'll have a complete dedicated session for rate limiters. We'll discuss all the 5 type of rate limiters and how do we use them or initialize them. Second thing that I would want you guys to take take a attention of is that, let's say your rate limiter that you have created, that's a logic that you have already put in place, but you would have the rate limiter at 2 levels, right? One is your IP base, one is your configured way, maybe your API key or user ID from your token, right? Your rate limiter logic should be in such a way that same code can be used in two middlewares, right? Right now, the rate limiter logic that I have applied is not taking care of IP or anything. It's just the logic over there. You will have to make sure that you create the right bucket for IP-based rate limiting also and a custom rate limiting also, and extend these logics so that we can have two type of middlewares now with the same code, basically, just different configuration. Hope the challenge makes sense for you guys for this week. Hello. So I'll stop sharing and I'll wait for next 5 minutes if you guys have any question, any doubts on the challenge or things that we have discussed today. Thank you guys for the reaction. I really appreciate you guys taking out time on your Sunday morning. And it was really early morning, I think, for most of you guys. So I really appreciate you guys joining the session. Any questions or doubts that you guys have? Okay. So then see you guys in the next week, and I hope you guys solve the challenge for the week, and we'll meet in next week. And also do join the Discord server link. I'll be sharing an email with all these reference link for the LinkedIn article, the API Gateway repository, and the Discord server where we'll keep discussing. You guys can keep asking question in the Discord server on the challenge. There is a separate channel created for this challenge there on the Discord server, and you guys can keep pinging me, or you can seek help from the people in the community, and people can keep giving their inputs on the challenge, right? So I would love to see a lot of interaction on this challenge in this week. Okay, then yeah, see you guys in the next week. We'll meet. next week. Bye, everyone.